Welcome, everyone. Welcome to Real World DevOps with Abel Wang. Abel Wang will be virtual today. He needs a bigger boat to come, so he will explain about that. But to introduce him, Abel Wang is a principal cloud advocate and DevOps lead at Microsoft, specializing in DevOps and Azure with background in application development. He's currently part of Donovan Brown's League of Extraordinary Cloud DevOps Advocates. Before joining Microsoft, Abel spent 7 years as a process consultant and a certified Scrum Master, helping customers globally develop solutions using agile practices and Team Foundation Server. Prior to that, Abel founded and sold his own software company. When not working, Abel is either writing code. Yes, that's what he does for fun. Playing his guitar or training for the Great Wall Marathon. Recently winning his fight against cancer, Abel spits in the face of cancer and will never quit. So I welcome you. Abel, do you want to go ahead and start the session?
Okay. Great. Can you all hear me? All right, perfect. Good morning, everyone. I am so excited to virtually be here. I really wanted to be here in person, except it's a little bit hard for me to get to the airport because my neighborhood where I live in, it kind of looks like this right now. And for me to get to the airport, I really would need to have a bridge. We've had I really need a boat. We had huge amounts of storms and total disaster. Everything's flooded and I can't get there. But with technology, I am now able to present virtually. Now, before I totally begin, I wanted to share with you guys another disaster that I ran into this morning as well. So usually what I do before I talk, I run through my demos one more time, right? So today when I ran through my demos, this is what I ended up seeing. Okay, here's my demo. Check this out. I refresh this and wait, that doesn't look good at all, right? That can't be right. But all of my resources, they're held and hosted inside of Azure. So I'm figuring, well, let me jump into the Azure portal and take a look. So when I jump into the Azure portal and refresh this, notice anything funny here? There is no resources in Azure. So apparently somebody has come in here and deleted absolutely everything in my resource group, which is absolutely crazy, right? But in theory, I should be okay because, again, I have something called technology and I use DevOps best practices. So if I just queue my pipeline up, I should be able to rebuild everything, rebuild my application, deploy all the resources that I need out in Azure, provision everything, and then deploy my application because I did use things like infrastructure as code. So let's go ahead and do that. Let's just go ahead and create a release. And what could possibly go wrong in a live demo like this, right? So we'll go ahead and create this release. And while I'm talking, it should just go ahead and build out my entire demo for me. And when I'm done, if the demo gods are good to us, then everything should be fine and working by the time I'm done talking. All right, so let's jump back to the presentation. For those that don't know me, let me do a quick intro. My name is Abel Wang. I'm a principal cloud advocate and also the DevOps lead here at Microsoft. My claim to fame is I've been writing code for freaking ever. I love writing code. I eat, drink, live writing code, right? That's pretty much who I am. I'm also really lucky because I lead a team of 5 DevOps practitioners, and our sole charter is to help everybody get into Azure using DevOps best practices. So if any of y'all have questions or have concerns or have anything at all and need to get into Azure using DevOps best practices and don't know, feel free to reach out and ask us. How do you get a hold of us? Do not email. Because if you email, I probably won't see it for at least 2 weeks because I'm so behind in my emails. However, I'm on Twitter all the time. So if you tweet at me, and especially if you hashtag it, LOECDA, that will literally light up a team room for us. We will see your questions and I will answer your questions. And if I don't know the answer, I will find the people at Microsoft that will. So please, please, please do use us. We are a resource. We are here to help. All right, so today we're going to talk about DevOps. I am super passionate about DevOps, right? But what exactly is DevOps? You people in the room, what is DevOps? And you'll have 20 different responses, right? So in order to frame this conversation we're about to have, let me give you Microsoft's definition of DevOps. So for us, DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. Now, I said this really carefully because every word has it, right? I didn't say continuously deliver code, because ultimately, what will that give us? Piles and piles of code sitting in some source control system. Really, who cares, right? And notice I didn't even say continuously deliver features, because man, I could be delivering feature after feature, sprint after sprint. But again, if this is not what our end users need or want, why are we wasting the time in doing this? We need to make sure that we continuously deliver value. And of course, the million-dollar question is, why is this so important, right? Why is DevOps so important? Well, really it's pretty simple. The speed of business today is so ridiculously fast. The only way dev teams and organizations can keep up and innovate fast enough is if they adopt DevOps best practices. Now, here's the key. If you don't adopt DevOps best practices, your competitors either have or they will, and once they do, they will out-innovate you. Not just by a little bit, but by a lot. And once they do that, what happens to us? We become obsolete, right? And none of us wants to be obsolete. So I've been DevOpsing for a while now, and I've been giving talks like these for about 7 years. And when I started talking about DevOps, I would say things like this, but I didn't know for sure if this was true. Like, I felt it in my gut. I really thought it was true, but I didn't know. However, now in 2020, we've been DevOpsing long enough that we absolutely know, with empirical facts, beyond a shadow of a doubt, teams that adopt DevOps best practices absolutely out-innovate teams that don't, right? So this is why it's so important. We must adopt DevOps best practices. However, it's not easy to do DevOps correctly. So you really have to address all three of these pillars: the people, the process, and the products. The people portion, that's the hardest thing to do, right? Because ultimately what you are talking about here, you're talking about culture. I can spend an entire hour just talking about the culture that's needed to enable DevOps, to be successful in DevOps. The people portion, that is the hardest portion to address, and it is absolutely the most important thing to do as well. We don't have an hour because this is not what this talk is about, so I'm not going to spend an hour talking about culture. However, I will just say this: you need to have a culture starting from the very, very top of your organization all the way down to the bottom, where every single person is hyper-focused on continuously delivering value, no matter what it takes, no matter what you need to do. Next is the process, right? This is pretty easy. You need a process that will let you iterate fast enough, yet still deliver high enough code. So processes that are like Agile-y type of processes work great. Things like Agile, things like Scrum, things like Kanban, things like that, right? Those types of processes work great. And finally, you need to have a set of products that can help enable all of this. And it's pretty difficult. So ultimately, we need to make sure that we have processes that can do, or I'm sorry, tools and products that can do all sorts of stuff. So for instance, we need to have our tools be able to plan and track our work, track using visual tools. So we need things like backlogs and Kanban boards and things like that. And for our developers need tools as well. So they need to be able to check their code in and out of source control. And as soon as they check their code into source control, it needs to kick off automated builds. And these automated builds will compile everything. It can run all of our unit tests. And if everything looks good, then I need automation to go ahead and pick up those bits that were built and then start deploying it into my dev environment, QA, UAT, all the way even out into production. And I need these to be automated, right? This process, it has to be automated because this could be happening hundreds of times a day even. So what happens when human beings try to do everything? We tend to make mistakes, right? So an example of this, there was a very young developer at Microsoft who pushed code into dev and he started testing. But this young dev forgot to change the connection string in his web config. So his connection string was still pointing to production database. So as he was testing, he was absolutely wrecking production data, right? Very, very dangerous, really bad. Luckily for me, this idiotic developer did not delete or did not get fired because it was me that did it. And as embarrassing as it is for me to admit that I actually did this many years ago, it's not that uncommon, right? Because ultimately, as human beings, we tend to make mistakes. So we need this process to be automated so that it's repeatable every single time. And so that it is consistent every single time that we do this. And finally, once our code hits production, it doesn't end there. Because once your code hits production, you need to be able to monitor it. You need to be able to know, hey, what are people doing in my application? Is it up or down? Is it even performing well, right? And if I know things like that, that will let me figure out, am I delivering value in my last sprint? And if we are, that's awesome. We can double down on this and keep on doing things like this. And if we notice that, people aren't using this new feature that I wrote or performance is bad, we can immediately look at that. And if we're going to fail, let's fail fast, right? So if people do not find value in the new feature that I created, we can immediately abandon that, redirect our resources to doing something where they will find value. So this is the type of processes that we need. And lucky for us, there are tooling that does all sorts of this stuff, right? There are open source toolings, there is closed source tooling, there's all sorts of toolings that you can use. Or there's also services that are built inside of Azure itself that can do all of this for you as well, right? So do I care what type of tooling you all use? Absolutely not. Azure is an open system, which means you can use whatever type of tools that you want to get your code into Azure. So right about this time, this is when I usually show a demo. Now, when I create a demo in conferences, they're usually beautiful. It's rainbows and unicorns, right? I mean, we're talking, I make a little change, you see me check it in, you'll see the build kickoff, you'll see the unit tests are running, you can see deployments happening, automated UI tests are running, everything looks so incredibly cool. And within like 5 minutes, we look at the screen and the new changes has magically pushed all the way into production, right? Yay, rainbows and unicorns. However, that's not very real world like, right? Because in the real world, especially if you do a lot of DevOpsy type of stuff, it's much more like this. In the real world, DevOps tends to turn into dumpster fires. So what I want to do today was kind of walk through a real world application with a real world pipeline, warts and all, so that you all can see that using DevOps best practices, you can solve just about anything. So for this presentation, we need a real world application, right? So the application I figured I would use is going to be a modern microservice-based application. It has an ASP.NET web front end. And I do mean ASP.NET, right? Not .NET Core. This is old school ASP.NET web front end. It does have a relational database in the back, a SQL Server database. It also has some modern portions to it as well. So it has a REST API that's written in Node, and I need this to run inside of a Kubernetes cluster. There's also a services layer, and this is going to be written in .NET Core that I also want to run in a Docker container. And also, there's going to be an iOS and an Android portion as well for this application. Now, once I wrote this application, and I tried to start building up my pipelines, I immediately started hitting real world problems. So what type of real world problems am I talking about? First of all, my application was not ready for real microservice deployments. Now, one of the biggest benefits that you get from writing microservices is that when you make a change to a microservice, you don't have to deploy absolutely everything. You can just deploy the microservice that changed. It's a much smaller deployment, so that's much easier to push out. The change is much smaller as well, so it's much easier to test, right? So in my mind, I was like, awesome, this is gonna be super cool. I'm just gonna go ahead and create some small pipelines and like maybe 5 or 6 small pipelines. This is gonna be super simple, right? So I did that and I ran these pipelines and it worked 2 times. Yes, 2 times only. And then it broke because I forgot that with all these different microservices talking to each other, versioning matters and also dependencies start to matter from one service to the next, right? So for instance, if service A depends on service B, now the order that you deploy your microservices starts to matter. Because if you deploy them in the wrong order, your application is going to be down for a little bit. It's going to break for a little bit, right? And ultimately, I want to have no downtime. So then the more microservices that I have, it starts turning into a colossal mess because, again, the order that you deploy matters. And it's hard to programmatically figure out which services that I need to deploy first, right? I ran into an even worse problem with this as well, because let's say service A depends on service B, that depends on service C, that depends on service A. Uh-oh, now what do I do, right? How do I deploy my microservices to make sure there are no downtimes? The answer is, well, I actually came up with a solution. I figured I could make my services really, really smart, right? So my services can actually talk to each other. So I can say, hey, you, service A, what version are you at? And you can be like, oh, I'm on version 29. And I can be like, oh, I was hoping you were on version 30. So but that's okay. Let me turn off my version 30 feature flags. Let me turn on my version 29 feature flags. Now we can totally communicate. We have no issues whatsoever, and everything just magically works. And the order that I deploy my services totally doesn't matter now. Yes, problem solved, right? However, I know that works in theory because we do this a lot in a lot of the services that we have at Microsoft. However, it's going to take a little bit of time to do that. I mean, the code is not crazy hard, but it takes a little bit of effort to write that. And at this moment, I don't have a single line of code written to have my services be smart. So what can I do right now? Because right now, I still need to push changes out in production, right? So right now, the unfortunate truth is I have to treat everything like a monolith until I can truly separate out the dependencies between my services, right? So think about this really carefully. Yes, microservice architecture gives us a lot of benefits, but until you seriously take all your services and make sure they don't depend on each other, there are no dependencies. Until you do that, you have to treat everything like a gigantic monolith. All right, that's unfortunate, but for now, that's what I need to do. The next thing that I ran into is that the infrastructure is incredibly painful to spin up and configure, right? Because there's a lot of moving pieces that I need. I need to spin up an Azure App Service. I need to spin up a SQL Server database. I need to spin up a Kubernetes cluster. I need to spin up Azure storage, some Azure functions, right? Just a whole bunch of these things that I need to set up and also configure. But where it gets really, really even more messed up is just to set up and just to configure everything. That will take me about an hour, a little bit more than an hour, just to configure everything and set everything up every single time I do this. And as I'm deving and as I'm doing stuff, I have to tear down my environments and reconfigure them all the time. There's got to be a way that I can do this without needing to go into the portal and manually clicking on everything, which again takes for freaking ever. Right? Excuse me. All right. Another real world problem that I ran into is that my microservice architecture right now is proving to be a little bit difficult to join together. And what I mean by that is because all of these microservices actually exist with like different domain names, when they try to communicate with each other, I'm running into CORS issues, right? Cross-domain problems, which can be solved with just a little bit of code. But again, maybe there's a way I can solve it without making any code changes, because that would make my life easier, right? Some other problems that I have a relational database. How do I manage relational databases in a DevOps world, right? Because usually a DBA looks at everything, make sure it looks good, and then they are the ones that manually run these scripts. So if I do that, that's going to be a huge bottleneck. I want to be able to automate all this. So is there a way for me to do database DevOps? Next is mobile DevOps, right? There's a mobile portion, iOS and an Android app. Mobile DevOps is almost like normal DevOps, but there are some very unique use cases that mobile goes through. For instance, how do you test against all the millions of different devices that are out there? Or things like, how do you deploy just so that your beta testers can see it, right? Or your alpha testers, and how do you even get it to the store? Do you have to do this manually? Are there ways that I can automate this process? And things like that. The next two, maintaining quality and security, these are important concepts as well, right? So we can, in theory, build out this pipeline where we can just make one click or make one change, and it'll push our changes all the way out into production. So if I'm doing quality checks, usually the way I do it is I write my code, and when I'm done running my code, a QA tester does end-to-end functional tests to try to find all of my bugs, and then I go ahead and fix it and rinse and repeat until we're all done, right? That works, but it takes a really long time to do this, right? So if my code base is pretty big, it might take a week to do all the testing. If my code base is a little bit bigger, it can take weeks, it can take months. If your code base is as gigantic as Windows, it literally can take over a year just to do all your tests from the beginning all the way to the end, right? All your functional testing. So clearly in a DevOps world, we don't have time for this. And we don't want to just be pushing bugs or security holes into production super fast either, right? So how do we maintain quality, and how do we maintain security in a DevOps world as well? Security is kind of like with quality. How do we do security right now? Usually you write your code, then a team of security experts will come in, audit the code, and they'll spend weeks, months auditing your code to make sure it's you're not pushing security holes out, right? So again, we don't have that time. How do we maintain security in a DevOps world? And finally, setting up DNS and HTTPS as well, because this is a real world application. You have to have DNS, and you also have to have HTTPS. So I need to figure out all of these things. And apparently, I figured out what the answer is, how to solve all of this. And the way that I solve all of this is through what I like to call DevOps Nirvana. I am able to build out a pipeline that can do almost anything. So now's the time for a real world DevOps demo, right? I think what I'm going to do is dive into my pipeline and really show you step by step everything that I did. Now, the important thing to remember, this entire demo that I'm showing is using Azure DevOps Services as my CI/CD pipeline, and then I'm deploying everything out into Azure. You don't have to use Azure DevOps Services. You can do exactly what I'm doing using things like GitHub Actions. You can using things like Jenkins or Spinnaker or whatever. Really, what I'm trying to do is just to show you all the possibilities of what you can do. And yes, I'm hosting everything up in Azure, but again, it doesn't have to be in Azure. We can apply the same principles that I'll be showing into, well, behind your firewall on-prem. Right? You can use these same principles even going into other people's cloud as well, right? So this is, again, I'm showing things using Microsoft Text because, of course, I work for Microsoft, but it doesn't have to be in Microsoft Tech. All right. So let's go ahead and dive into the demo. All right, so it looks like our deployment is all green, which is good. So that means my demo hopefully is working. And remember, everything starts with my build, right? If somebody makes a change, that's what triggers everything. Now, also, at this point in time, I haven't made my services smart where they can truly be independent and not dependent on each other in any way, shape, or form. So because of that, I have to treat everything like a gigantic monolith. So my build has to be a gigantic monolithic build as well. Everything starts with my build. I have one build that will trigger my web front end, my mobile application, my services layer, and also my API layer. All right, so for the web front end, this is a pretty simple build, right? I use a Windows agent that comes with Azure DevOps Services. I restore my packages from NuGet. I use White Source Bolt to do a security scan. What is White Source Bolt? It is not a Microsoft product. It is written by White Source. And what this does is it goes through my source control, and it looks at all the open source projects that I use. And it looks at the version of the open source projects that I use. And it looks at the APIs that I call. And then it will create a report for me saying, hey, you're using an older version of whatever open source project that I'm using. These are the security holes, and you're calling APIs that hit those security holes, so you need to upgrade quickly, right? Or it can even tell me things like, it does have security holes, but the APIs that you're calling are actually safe. So in theory, you're okay, but you might want to update anyway, right? So that's what White Source does. Basically, what I'm trying to show here is that you can put in tasks in your CI/CD pipelines that can help scan your code, that can help try to hack your code, that can try to find security holes, or it can, all of these types of stuff. So what type of security tools are available inside of Azure DevOps? If you go to the marketplace and just type security, you're going to end up with pages and pages and pages of different types of security tools, right? So you could just start scrolling through this list and you'll see all kinds of different security tools. So what do these security tools do? There are tools that can scan your code for credentials that have been leaked. There are tools that will take an application that's already been deployed and try to do SQL injection attacks against it. There are fuzzers out there that will go ahead and try to hack your sites that have already been pushed out, right? So there are all types of different security tools that you can put within your CI/CD pipeline that will help you find your security holes before they get pushed all the way out into production, right? So if we don't have time to bolt on security at the end of our application, that means while we're building our application, we need to build security into what we are doing. And one of the ways that we can do that is with all these different security tools that can run during our build, during our pull requests, and also during our deployments. All right, the next thing that we did, I built my solution using Visual Studio. Then I go ahead and run all of my unit tests. All right, so here's where I can become just a little bit controversial. I am a huge fan of unit tests. And in fact, I would say that you cannot be successful in a DevOps world without unit tests. Why? Because unit tests, they are our first line of defense and also our last line of defense. And they are our best line of defense for quality issues. To give you a sense of just how important unit tests are, Azure DevOps Services, we write unit tests as well, right, for all the code that we write. Azure DevOps Services is one of those applications that cannot go down ever because it's literally holding everyone's source code. It's holding their build and release pipelines. It's holding their CI/CD pipelines, their plans. Basically, if it goes down, other people can't get their business done, right? So it cannot go down. So what you're seeing on screen right now is the quality dashboard of Azure DevOps Services. And literally what we're doing here is there's a giant grid that is filled with a lot of reds and greens and blue squares, right? So every single build has to go through all of these different levels of tests that we write. But what I really wanted to show you all was our pull request. Find a pull request. So here's our pull request. So let me go ahead and jump in here. Every single developer check-in has to go through a pull request, right? So we have to review each other's code. So what I'm going to do is I'm just going to pick any random pull request. And from here, remember, every developer check-in has to go through a pull request. The first thing that it does, it has to run through our build. Our build compiles everything, and it also runs all of our L0 and our L1 tests, which are our fastest running unit tests. If you take a look, every developer check-in has to go ahead and run all of our L0 and L1 tests, which means every developer check-in has to run 28,866 unit tests. And we all do all of this in less than 3 minutes. So I don't want to hear about it can't be done or it's too slow or whatever. It works. We do it and it works incredibly well. How important are unit tests for us? Yeah, 28,866. How can we move at DevOps speed where we're pushing code out into production every 3 weeks like clockwork? And Azure DevOps Services rarely ever goes down in any way, shape, or form because we have these unit tests. Twice a day, actually multiple times a day, we push out bug fixes. How can we move that quickly without just wrecking stuff all the time, right? Again, because we run 28,866 unit tests. All right, enough of me preaching about unit tests. After we run our unit tests, I package everything up so that it's ready to be deployed into my Azure App Service, because this is my web front end. Next, I build my iOS application. So what is this iOS application? It's just a mobile app. First thing I do is I install my certificates, and then I do this replace token thing. So what is this replace token, right? That's a little weird. So what I'm doing there, you know what I should do? I should just show you the source code. So let me go ahead and pull up my source code to show you exactly what I'm doing. Let me go ahead and jump into the right directory. And let's go into, my code is in GitHub. And we'll go into my repos, and let's see. There we go. This is the full one, and let's go ahead and launch code. So my mobile app is kind of interesting because I'm not a mobile developer, right? I mean, I know how to write mobile apps, but I don't really do it usually. So what I ended up doing was I wrote my app using Xamarin because I know how to write C#. So I was like, oh, that's just super easy. Let's just do it that way. But I ran into this weird issue because my mobile application needs to hit backend services, right? And my backend services, those URLs, that's going to be different in my dev environment versus my production environment. So how do you configure what your URLs are? In a web app, I know I would just stick it in some configuration file, throw that onto my web server, and pray for that I'm done, right? When I looked at my mobile apps, I could not find any type of configuration files. So I didn't know what to do. So I pinged James Montemagno, who is our mobile guru, and he looked at me and said, no, you can't put it in a configuration file, because if you put it on a configuration file, that configuration file literally sits on the handset of everyone's devices, which makes it incredibly easy to get to and to hack. And I was like, oh, you're right. That's not good, right? So what do you do? And what he told me was, well, we just hard code the URL that we need to go to into our source code itself. So in the dev environment, we would hard code the dev URL, build our application. Then we would hard code our production URL and rebuild our application again. So I'm like, whoa, hold up a second. Are you telling me that we are doing multiple builds of the exact same version, and the only thing you change is the URL in your source code? And he's like, yeah. And if you've ever met James, or if you watch his videos and stuff, he is probably the most cheerful person on earth. And it just annoyed me to no end. I really kind of wanted to punch his smug little face right then and there, because this breaks all DevOps best practices. You don't do multiple builds of the same version, because if you do, stray code potentially can and will flow into your different builds at some point in time. And then you'll have the very unfortunate time where your dev build is different than what you actually deployed into production, and then things don't match, and the testing, it doesn't match or work either. Right? So I came up with a better solution, or at least I think is a better solution. So what I did was this right here. So what you're looking at right now, this is the source code to my application. This is what James wanted me to do. Hard code the actual URL, right? So this is what we do over here. That sounded ridiculous to me. I said, there's got to be a better way to do that. So I created a property called getFoodLogsURL. And what I need is I need something to hold a table, and that table can just say, hey, for this version of your application, it's in the dev environment, and while it's in the dev environment, this is the backend service of the URL that you need to go to, right? And if it's in the production URL, this is the URL that it needs to go to. So that's all it needs to do. And if I could just create a REST API where I can set and get the values, I'm set, right? So what I did instead is I had a build number, and you notice I've tokenized it. So during my build, I can burn in the build number, and then in my code, if I need to get my backend URL, the get food logs URL, I'm going to hit my REST API where I pass in the name of my app. I'm going to pass in the build number, and I'm going to pass in which URL that I want to get back. And now it will return me and it'll tell me, hey, you are currently in the dev environment and this is your backend URL, so use that URL. So dynamically now, I'm able to figure out which part of what my backend URLs are, all with one build. I don't have to do multiple builds. So this makes me really happy. So if we jump back to my build, this is exactly what my replace token does. What it's doing right here is it's burning in my build number into my source code. So when I compile it, the build number will be part of the binaries itself. Then I go ahead and restore my packages from NuGet. I build everything, and now I have binaries that are ready to be deployed. Hooray for that. All right, my backend services, remember this is written in .NET Core, so I build it, I turn it into a Docker image, and I push it to my Docker container registry. And for my API services, remember this is written in Node and it needs to run in a Kubernetes cluster. So if I need to deploy this into a Kubernetes cluster, I'm going to use Helm. So I create a Helm package and hooray for that, right? Now it's ready to be deployed. My Helm package is ready to be deployed into my Kubernetes cluster itself. Now, assuming this build works correctly, what should happen next is it should kick off my release. So let's go ahead and take a look at my release pipeline. My release pipeline is pretty intense. Let's take a look at it. So it's pretty huge, right? It's doing a lot of different stuff. And that's okay, because I need my pipeline to give me that DevOps Nirvana, right? So the very first thing that I do is I deploy a set of infra tools. What are infra tools? These are a set of tools that I use to help me deploy the rest of my application into the environments that I need, right? So these are just internal tools that I use to help me deploy. The first thing that I do, let's go ahead and drill in here and we can see exactly what I'm doing. The first thing that I do is I decrypt all of my secrets from Key Vault. Why Key Vault? Because Key Vault is freaking awesome, that's why. Sure, I could store my secrets inside of the variable sections. I can encrypt it and then nobody can see it and all that good stuff, right? But I really like Key Vault because I use the same keys and secrets in a lot of different pipelines. So if I change them, now I have to find every single pipeline that I'm making these changes in. And it's just easier in Key Vault because I can store it in Key Vault, I can encrypt it in Key Vault, and using one task, it will grab my secrets from Key Vault, decrypt it, and now I can use it. And if I need to change it, I just change it in Key Vault one place and it magically changes absolutely everywhere, right? So Key Vault, super easy to use, super, super cool. So I decrypt my secrets from Key Vault. Then using infrastructure as code, basically I'm using a PowerShell script and also using the Azure CLI, the Azure Command Line Interface. Why did I use PowerShell? Why didn't I use Bash or something like that? Well, it's actually pretty simple because I happen to know PowerShell a lot more than I know Bash, which means while writing these, writing it in PowerShell means I have to Google it a lot less than if I use Bash, right? But you can use Bash, you can use whatever scripting language you want. Basically, I'm just using the Azure CLI to provision what I need. And what I need for my infra tools is going to be an Azure function and also Azure storage, right? So then I go ahead and deploy my Azure function into the Azure function that I just provisioned. So what does this infra tools do? Let's go ahead and take a look. Here are my infra tools. Let me zoom in here so you all can see this a little bit easier. Let me zoom in. There we go. The first thing that I have is a DNS alias checker. So what is an alias checker and why do I need it? Basically, this just checks my DNS. Remember, I am doing a real world type of pipeline, which means I have to set my DNS values as well. There happens to be some infrastructure that I need to deploy inside of Azure that literally won't let me provision it or configure it until the DNS that I want to use has propagated all the way down locally. This is ridiculous. I didn't think about this, but it's very real worldy, right? When we're doing real world pipelines, strange things often come up, and this is one of these. So what I needed was an ability to say, hey, did DNS propagate all the way down to the local agent that I'm trying to deploy yet? So that's all this DNS alias checker does. It's an Azure function where I can say, hey, this is my alias. This is the DNS value that I need. Did it propagate down yet? And if it did, it'll return yes. If it didn't, it will return false. The next thing that I have is an infra version retriever and updater. And what is this? All right, so the infrastructure that I'm using, remember I said I'm using the Azure CLI with in a PowerShell script, right? So for infrastructure as code, if I'm doing infrastructure as code into Azure, there's usually 3 different ways we can do this, right? We can use ARM templates, we can use scripting using the Azure CLI, or we can use a third-party system like Terraform or something like that, right? I thought about using Azure ARM templates. ARM templates are super powerful and super flexible, but for this demo, I didn't want to use ARM templates because they're, for lack of a better term, they're kind of a pain to use, right? ARM templates, they're hard, super powerful, but every time I run them, if there's an error, I get this cryptic error message, and it takes me a long time to get them just right. Writing a script using the Azure CLI seemed much easier, so that's why I ended up doing. Now, when I wrote my scripts, one of the things, these scripts have to be idempotent, right? Because these scripts are going to be part of a pipeline that gets run over and over and over again. So idempotency just means that I can run these multiple times and it won't break, right? So I can say, create me an app service with name XYZ. The first time I run it, it will go ahead and provision for me exactly what I need. The second time I run that very same script, like if I fire off my pipeline again, idempotency means that it will recognize that I've already created this app service and then it won't. It'll just no op for me. So the Azure CLI in theory is supposed to be idempotent. But when I created my pipelines, what I found out is the Azure CLI is only sort of idempotent. And by sort of idempotent, what I mean is that some stuff is idempotent and some stuff is not. So my next thought was maybe I should go ahead and jump. Oh, I'm getting a message saying that we're time for the panel. Is that true? Okay, so if it's time for the panel, I should stop this presentation, right? Let me wrap up super quickly then. So when I created my pipeline can do everything. Deploy absolutely everything, including my infrastructure, including setting DNS, including setting my Kubernetes cluster and deploying everything. It can do absolutely everything. So proof, let's jump into my Azure resource group. I can refresh this and you can now see I have a new resource group. I've now deployed everything that I need, including my app services, my databases, my Kubernetes cluster. And if we go ahead and restore my application, bam, there it is. It's all been all the way deployed. On top of that, not only did I store my database, I restored my data as well within my pipelines, right? Because database, before it got deleted, everything gets, the backup is automatically created. And so I'm just restoring my packages from backup. So not only did my pipeline create all of my infrastructure for me, deploy my application, it also did disaster recovery for me. So what can you do with these pipelines? Pretty much whatever you can think of. So go out there, start building these amazing pipelines. Your imagination's the limit. You can make these things do just about anything. All right, thank you all very much. And I guess it's time for a panel.